Thank you for allowing me to present this subject to you today. I'm really happy to be with you. So just a little presentation of myself. So I'm Damien Hackett. I'm a contractor for a French company, a contracting company, and I work for the client Eaton, so worldwide known for UPSs and all electrical products, American, and I'm in an embedded world since 10 days now, and 6 years for Yocto. So started on this release. So now we are non-build, so long time. And as you may have know, as you introduced, we'll talk about several OSs today, not only one. So we'll see what the casual case we have with Linux only, and some new OSs you may know, and we will gather them on the same SOC. So Opti and real-time OSs. So what's the embedded casual case? So in French, we have an expression. It's we want some strange meeting of features. We talk about 5-legged sheep, so kind of mythical creature we cannot find. And for embedded systems, is some of the case. A lot of specification, and we cannot meet sometimes. So for embedded system, we want a lot of connectivities, for example. So basic systems with Ethernet or Wi-Fi or some IoT or some specific network norms or something. So like 4G, 5G, and LoRa VLANs. We also need a lot of features for our clients. So user management, REST API to have an advanced web UI, and also easy configuration for users, backups, so on. Of course, we want real time. So we have all some critical operation to do in a product, which is the core of the product. Of course, we want cybersecurity. So we want hardened the system and kernel. And for us developers, we want something easy to do, so easy to maintain, and so can use high-level language, no assembly, nothing. C or C++ is good, or Rust if we can. We want also we use a lot of open source software, reinvent the wheel, and easy integration. So that's what Yocto is for. So we could say that for all of them, Linux could be a good choice. So okay for connectivity, a lot of drivers, a lot of supports, features too. Everything's run of Linux today. So we have also a lot of embedded system for creating REST API, web servers, and so on. For easy to maintain and for devs, also we are at home, especially with Yocto. Everything integrates fine, and so on, and cybersecurity, we can do maybe more better. So for real time, we have Xenomai, if we want to do hard real time, but is Xenomai really enough for some needs? And for cybersecurity, Linux could be could be hardened and secured, but it's for cybersecurity we already need to have several layers of security. So if some hackers have root access or can have some kernel access, kernel layer access, if there are nothing more, we have all the system is taken. So what can we do in this case? So we'll see. And also, if we start with Linux and try to add some patches, some add-on and so on, maybe we have some another mythical creature, but a bit ugly. So maybe you could arrange that better. So we say for Linux, so the 3 points, the 3 main points will remain for Linux: connectivity, user feature, and easy to maintain and develop. But for enhanced cybersecurity, we will use Yocto for so we will see secure boots, and also isolated crypto. And we'll have also a Netherite real-time OS running on the SOC. So let's talk about Opti. So many of yours may know what Opti is. It's open ported trusted environment execution. So it's like a UEFI for ARM. So hardware isolation between secure world and non-secure world. So Linux will and U-boots will run in non-secure world, and we will have Opti that run in the secure world. So we could specify which peripheral could run in secure world. So we could isolate some crypto core, hardware crypto core only for Opti. That way, we cannot access them from Linux, and we will have some discussion between Linux and Opti to access this peripheral in a secure way. And also with Opti, we have the secure boots. So with the chain of trust of each part of the boot. So starting from ROM code, we'll check the TFA, which is a minimal boot system, boot firmware, which we check and run Opti, we check and run U-boots, and so on for Linux. So that way we will not have some malicious binaries between. We cannot have a malicious Opti or malicious U-boots. It's all signed and checked, and the keys are stored in the one-time programmable register. For the project, we use the STM32MP15 processors with C options, enabling the secure boots capacity. And so I'll talk about secure and isolated crypto. So we could the hardware secure elements only for Opti and give access to them to Linux. So for that, we enable PKCS 11. So PKCS 11 is a cybersecurity norm, API, in fact, which gives some functions to do some encryptions. So here in Dunfell, so we use a Meta STM STM32MP layers for Yocto builds, and in Dunfeld, the 3.12 version only have support for symmetric keys. So we do a lot of POC with that. So do some encryption, decryption with through Opti, through the so we have a library interface to a library of supplicants, which offers a PKCS 11 function. And that way we talk to the supplicants, we will talk to the Opti parts, we will do all the crypto, so all the private keys will remain in the crypto, in the secure world, and we only have the results. And on Keystone, they have an update, and with 3.16 version, they added asymmetric key support. So we did some tests for certificates too, for example. And how to enable that? So all the default configuration could take a lot to explain here because there are a lot of things already done in MetaST STM32 layers, and we are only for PKCS 11 we only have to add some configuration to enable it. So it's here. We see how to improve cybersecurity. So now, for the other part of the topic about real time, how can we do that? So the secret is that, in fact, on the STM32 MP15 series, we have, in fact, two processors, and two processors of two different kinds. So we have the main processor, the A7, where Opti and Linux will run, and we have a co-microprocessor, Cortex M4, where we plan to run some either bare metal or yeah. So the idea is to run a specific specific OS built and cross compiled, especially for the M4. So we do some specific tests, or just hello world for bare metal, and we tested with FreeRTOS and Zephyr also. And in fact, in the process, we currently build the firmware for the M4, included in the Linux image, and Linux will load the coprocessors. That way, we don't have to also have a specific signature for the M4 firmware to be tested during the root of trust secure boot of secure boot. So it's directly embedded in the Linux image, which is signed, so no problem about that, and load by Linux at runtime, like another process, in fact. And so for the moment, this part has not been completely integrated. So in fact, we have a legacy. All of us may have legacy of RTOS firmware that run on maybe previous version of our board of our projects, and which run well, but we want to adapt to a new, more connected, so with Linux system, and so we can reuse it, and we plan to fully integrate it. Some of the motif config in the project for generating, for example, init from FS or so on. So in good way to be done. So of this RTOS, instead of directly use old legacy code, we have at Eton there are some project on production projects, especially on STMP. It's fitting. We have isolation, so even for the roots of the product, even if there are the network of the networking, so no monitoring, no control, especially on the UPSs, but the UPSs itself still could work. So no power outage. It could be good for the hospital, data center. So good to be splitted. And yeah, so I already said about the secure boots. And also, we don't have it on our project, but it could be also a good option if we want to turn off the A7. So that way we still have some core features running, and we could have we command to wake up the A7 when we want. The con could be yes, even it could even if they are the same thing, we could have some rework to do to especially for the communication data structure between M4 and A7, and multi-config also could take some time for smoothly integrating that, and also for some projects we don't have legacy work on M4, so we have to do the reverse path to split the code and only do some core operation inside M4. So it could be also extra work, but for me, it's worth it. And we also have for all the tests, we also have to do some more specific tests on the, as there are two different processors, we have to do different tests to test each part. So unit test, but also integration test. So I don't know if I'm on time or not. I could have some. I had some slides, maybe for question. I don't know if we have if we are good
You
or
still have
maybe I could.
20 minutes. We have 20 minutes until the start of the next talk.
Oh,
So,
okay,
yeah.
okay. So okay,
I,
so I will
or,
continue on my two. I have two slides, three slides as appendix. I don't really. So I will continue on this one. So, in fact, why I present it to you today, it's because one of the competitor of my clients of Eaton, so APC, to name it, part of Schneider Electric, have run into the Armis, cybersecurity company, find some free CVEs and gathered they call it Storm, and in fact with the free CVEs they can turn UPS to flame, so keep burn to completely a UPS from cloud. So that's why a TS storm from Zeus or gods, and so here, so I listed all the cities here. So the two first are more related to clouds and communication between clouds and the UPS. So not they have to fix that, but not really part of the embedded world. One of the major flaw was they have an unsigned firmware upgrade system, so no secure boots and not even um, check of the firmware signing between a bootloader and after an upgrade, they don't check it's not malicious. So if they did that, the problem cannot happen. And also, in fact, they managed to make burn the UPS because so they load a malicious firmware that do stop and start very quick stop and start on the battery on, of the UPS. So after a lot of switch on, switch off of it, they succeed to to make it burn. So with all the things we see before, especially for cybersecurity. So with Opti, we guarantee the signature. We have the root of trust and the secure boot. So we cannot have the we prevent malicious firmware to be uploaded and loaded by the devices. And so for crypto could help also for the second point because all the for TLS and so on, we could have some protection on the certificates and private key. But the main part here could be on the RTOS and the coprocessor side. So as we have a separated OS that handles the UPS core, even if the hacker succeed to take off to change the Linux, they still they still have to find a way to break the RTOS, and they have it add a layer of security. So it's not completely perfect, but it could add a layer of security. Okay. So there's also a new version of Tailstorm they found on Avaya and Aruba network switch. So it'd be the same mess that's it. And yeah, so I have other slide about so I talk a lot about STM32 MP1 MP15 ecosystem. Even I from Grenoble, I'm not part of ST sales. So I will I will show you that you can use. So of course, Opti work on a lot of other chips. So I listed some of them. So mainly supports ARM. I don't know if they are planned to support Flux5 or so on. But here there are some, so Raspberry Pi, of course, some TI, NXP, iSilicon. They also try to support some Xilinx Sync, but with all version now, not anymore supports. And about the coprocessor, it's a bit new, a new concept. They want for smartphones. They usually have some big little. So with before with A15, A7, now with other A77 or so on, and 8071. 33. So big little, but with the same brand, so with same Cortex A. For Cortex A mixing with Cortex M, there are NXP that do that. A bit of Texas Instrument, but this one don't have the so AM6 are not. There's some have part of the have also the Opti support, but not not all. And so for me, it's good to have both the better of the two worlds. So we'll see if you share the same the same opinion in your comments. So yeah. So I'll go back to it, and maybe we'll see your questions. So here I still see question about Yocto CI. I will show the Opti initial boot slide. Okay. This one. So about I see a question about debugging the M4. So the ID, there are some things called the IPC, so interprocess communicator. there are layer made by ST to communicate, so a specific bus, internal bus, to communicate between the two processors. Mainly, they use shared memory, so we could we could give some settings from Linux, get some answer from the F4 and so on. For debugging, yeah, I could admit that it's a bit harder, but in fact, we have with the ST ecosystem, we could have a debugger directly on the M4, so we could it could be seen as two different products. So we could have teams working on the M4 program, so debugging it, team working on the Linux parts, and together we develop the product. And in fact, it's the same. We have also some on some products we have lot of peripherals. So on some Eaton products we have some Modbus products connected on Modbus, and there are of course OSs, and so small OSs on this system, real-time OSs, and it's the same way. So there's teams developing the software for these devices, and team for the main boards, main connectivity boards, and so on. So yeah. So is there a question about the Opti initial boot slide or not? I don't have your. It's Lauren. No questions. So any remark or? So this is a proof of concept. For the moment, we try to find the pro and con of all the. So for Opti, it's part of secure boot, so we have to take it. But for the isolated crypto, it's still part of the POC, not yet integrated in the mainline product. But we see a lot of benefits from it, especially when everything's with everything integrated on the Opti side, even if there are some drawbacks like performances, but we are not we are not we don't do a lot of suffering, and so it's acceptable.
Yeah.
I see a question from Mark. Yeah, question about TPM. Okay, maybe just Mark was before on the M4. Okay, he answered to. Yeah, you could do some prints also. Yeah, on M4, in fact, you with device 3, you could set up which peripherals remain to each. So for you could have peripheral, especially for secure worlds or for Opti. You could have peripheral for Linux, and you could also reserve some peripheral for M4. So M4 could have. You could specify a debug port also for M4. The same way you could have a debug port for console shell for Linux. So you could debug also that way. But there are also GTAG and a lot of other stuff. Yeah. So about the question about TPM. So we tried TPM. So there are also a trusted application for Opti based on TPM made by Microsoft, and I don't remember, but it's not part of the Opti, not yet part of the Opti source. So we tried it at the beginning. We had some problems running it. So to do we don't have hardware TPM on the board. It costs too much for our project, so we don't want it to have it on the board. So we wanted a software solution, and so we tried soft TPM with Opti, and for us it was too much work, and for the same for the same advantage than PKCS 11 for our project, but maybe for others, but because we only wanted to do some crypto, exotic crypto, but maybe for some other features specific to TPM could worth it. But Opti have a special application for that.